Good day, mathletes. So today we're going to be talking about radical equations, all right? So we're going to have equations with radicals in them, right? And mainly the operative word radical applies to the variable, right? So there has to be a variable within the radical in an equation to make it a radical equation, all right? So there we go, equations which include radical expressions, right? Now, one thing we're going to have here is what's called an extraneous solution, so we'll talk about that in a second. But let me go through the procedure real quickly. So when you're solving radical equations, let me title this here, solving radical equations. What you're going to do first is isolate a radical, okay? And sometimes there's only one radical, so sometimes you isolate the radical, but I put a radical because sometimes you have more than one radical expression, okay? Now remember that if you have a rational exponential expression, that's the same as having a radical, so you kind of treat it the same way. So isolate the radical or the rational exponential expression. And then once you do that, then you're going to raise both sides of the equation to the power equal to the index, right? So so basically you might square both sides, or you might cube both sides if it's a cube root, square both sides if it's a square root, fourth power both sides if it's a fourth root, etc., right? So you raise both sides to the nth power where n is the index. Okay, so that's step B. Now if you still have another radical there, then you're going to repeat steps A and B. So then you're going to isolate the next radical, and then you're going to nth power both sides, and then and then if you still have another radical, isolate again, and so forth. But usually in the problems that we're going to deal with at most, you'll have two radicals, so you might have to do A and B twice. All right, so once you nth root or nth power both sides, that'll cancel out all your nth roots, after a few iterations of that, or like I said, up to 2 iterations of step A and B. Then you're going to end up with no more radicals or no more rational exponents. So now you can just solve like we normally do, isolate the variable, and then you're going to get, like x by itself, or v by itself, or p by itself, or m. And so once you isolate the variable, now you have your solutions, but what we have to do is we have to check for extraneous solutions. So that's something different with radicals. We'll see it with rational equations as well, but we want to check for extraneous solutions. And those are solutions that seem to work after having done, the algebra that we did to get to that point. But if you plug them back into the original, they don't work, okay? And so that's what an extraneous solution is. So let me show you an example. Now, we know this can't be true. If I have the square root of x equals negative, let's just say -2, right? We know that square roots only return positives. But if I were to try to get rid of this radical here and get x by itself, I would square both sides. And what would happen is the square and the square root would cancel out. So I just get the radicand. So this just becomes x. And then -2 quantity squared would be +4, right? So my answer would be x equals 4. And so this seems like it works, right? Seems like it would be fine. But if I plug that back into the original, I would get the square root of 4 equals -2. And we know that can't work, right? The square root of 4 equals +2 because it gives a principal value, right? Square roots return the principal value. And so that means that this is actually an extraneous solution. All right. So, and you don't have to write the word extraneous every time, but I do want you to recognize when you do have an extraneous solution and then cross it out. Okay. Now, it doesn't happen all the time, but it's something to watch out for. Okay.